Okay, so welcome back, and now we're going to go over inverse proportions. Okay, so what is an inverse proportion? Well, an inverse proportion is where two variables go in opposite directions. So as one variable increases, the other one decreases. As one variable decreases, the other one increases. Okay, so again, to compare with direct variation is where the two variables change in the same direction. They both go up or they both go down. Here, the two variables change in opposite directions. For example, if I'm talking about a trip, which in the example I'm going to do is talking about trips. If I'm going a certain distance and I know it takes me to go there in a certain amount of time going one speed, if I increase that speed, naturally, intuitively, I know it's going to take me a shorter amount of time to get there. That's inverse relationship. That's an inverse proportion that we could talk about. So let's do an example of where that comes into play. And then I'll show you how to set it up so that you get the correct answer. So if it takes 2 hours to go a certain trip, to make a certain trip at 50 miles per hour, how long will it take? How long will the trip take at 60 miles per hour? So I know intuitively, since I'm going faster, that my answer should be less than 2 hours, right? But I need to set it up right. So here's how you set up a proportion when you're dealing with inverse relationship. So again, I'm gonna look at A over B equals C over D. Okay, now we know that for these two fractions to be the same, as A increases, so does C. As B increases, so does D. So as A increases, so does B have to increase, and that affects C and D, right? So I said in the last video, so I want my two variables with the unknown to be on the same side. So I'm going to have my units of measurement be the same as the units of measurement here. Whatever I'm measuring here is going to be the same here, and same likewise for down in the denominators. With inverse proportions, it's a little different because in order to make one variable increase and the other one decrease, they would have to be opposites here. Okay? Because then if I invert one of the variables, if I invert one, then it will stay the same. Okay, so again, with inverse, I have to set up the proportions differently because if I know that A and C change inversely with each other, I can't have them on the top because remember, equivalent fractions means that as one goes up, so does the other. So the way I'm going to have to do this is I'm going to have to flip it. So I'm going to have to flip one of them. So I would have to do D and C. And then now, this would give me equivalent fractions. Okay? So that's what we're going to have to do for inverse, to set up an inverse proportion. We're going to have to flip one of the fractions. So let's set this up. So, and we're also going to have the units on one side of the equal sign. So I'm going to have speeds on this side, time on this side, and then of course I've got to invert one of the two. Okay, so let's set this up. So I'm going to have 50 over 60. Right? Now normally what we would do is we have the speeds here, right? If this is true, then I'm going to have the corresponding speeds or the times. And we normally would say, okay, 2 hours goes with 50. And so X goes with 60. But since this is an inverse relationship, we're going to flip this. And so we're going to have X over 2. So 50 goes with 2 crosswise, and 60 goes with X crosswise. Now we can go ahead and solve. And so now what I'm going to do is I'm going to multiply both sides by 2. And now I get X excuse me, x equals this. Now notice that x, remember, x has to be less than 2 hours, right? Because we're increasing the speed. So again, it should take less time. Now notice that 5, this is 5 over 6, 5 6, which is less than 1. So I know I'm taking a fraction of 2. So I know this is going to give me a number less than 1. So it passes the gut check, right? So this is going to be what? 10 over 6, or 5/3, or what? 1 2/3 hours. And again, you could check your answer by doing the multiplication. So you could take 1 2/3 hour, right? And multiply it by 60, and then take 50 times 2 hours and see if you get the same distance. You will. Have a great day.